125 million years. That's how long something has been waiting in the dark. Not hiding, not hunting, waiting. Because down there, survival doesn't look like movement. It looks like patience. It doesn't chase. It doesn't rush. Most of the time, it barely moves. Pink skin, almost translucent, a blade extending from its skull. Then it feeds. The jaws don't open, they launch. The entire face dislocates forward, 6 inches in 0.3 seconds. Teeth snap shut. Everything retracts, like nothing happened. This is Mitsukurina austoni, the goblin shark. It lives between 900 and 4,300 feet deep. Deep enough that sunlight is a memory. Deep enough that pressure could crush a human skull instantly. So it doesn't see. It reads electricity, every heartbeat, every muscle twitch. Your body broadcasts signals constantly. The goblin shark detects them through darkness, through water, through distance. It doesn't detect you moving, it detects you existing. Its body is soft, almost loose, because muscle costs energy, and energy barely exists here. Even its color has a reason. No pigment, no need. Pigment only matters where light exists. And the jaws? They solve one problem. You only get one chance. Move too much, the prey feels it. Create a pressure wave, it escapes. So the body stays frozen. Only the jaws move. By the time the prey notices anything, it's already dying. Now imagine something that doesn't eat. Not for a day, not for a week, for 5 years. 2007, Monterey Bay Aquarium. They offered it shrimp, fish, squid. It refused. 5 years, 1,869 days, not one meal. Then it died. Not from starvation, from waiting. This is Bathynomus giganteus, a giant isopod, a deep-sea relative of the pillbugs in your garden. Except this one is 16 inches long and lives 7,000 feet below the surface. Its shell isn't stronger, it's smarter. Segmented plates distribute pressure evenly, like architecture instead of armor, because brute force fails down here. Design doesn't. Its metabolism runs at 5% normal speed, heart rate nearly undetectable, cells barely active. Your body burns 2,000 calories a day just existing. The isopod burns 2,000 calories a year. Then one day, food appears. A dead whale, a sinking fish. Suddenly, they move, fast. No fighting, no chaos, just silent coordination. Because they all understand the same rule. This might be the only meal until 2030. In the deep sea, light is dangerous. If you can see, you can be seen. This one cheated. The deep-sea dragonfish produces light, but not blue, not green, red, a color that shouldn't exist down there. By 500 feet deep, red is completely gone. So when the dragonfish emits red light, it becomes invisible to everything except itself. In 2005, researchers identified chlorophyll derivatives in its retina, plant chemistry repurposed for hunting. These molecules shift red light into wavelengths its brain can process. It floods the water with invisible light, scanning, searching, and when it finds something, it strikes. Transparent, needle-thin teeth. It doesn't bite, it impales. Even its stomach is black-lined. Because some prey glow after death. If the dragonfish didn't contain that light, it would become a target. So even digestion is hidden. 7,000 meters down, 4 miles beneath the surface. At that depth, water doesn't behave like water anymore. You don't move through it. You exist inside it. This is the Dumbo Octopus, Grimpoteuthis. It doesn't jet like other octopuses. It can't. So it flaps. 2 fins like wings, slow, controlled, effortless. Its body is soft, almost transparent, because rigid structures break under pressure. Instead, its cells are filled with piezolites, molecules that stabilize proteins, keeping life intact when it shouldn't be. It doesn't use ink. It doesn't camouflage. Every unnecessary feature gone. Even reproduction changed. It lays eggs continuously. Because here, you don't bet everything on one outcome. You play probability. Notice what's happening. Every creature down here is defined by what it gave up. Goblin Shark gave up speed, kept precision. Isopod gave up metabolism, kept time. Dragonfish gave up visible light, kept vision. Dumbo gave up muscle, kept movement. Every adaptation is a subtraction. The deeper you go, the more you lose, until there's almost nothing left. Now meet the fish that lost everything except the ability to exist. There is a depth where fish cannot exist, not because of pressure, because of chemistry. At extreme depths, survival requires a molecule called TMAO. The deeper you go, the more you need. But there's a limit. Too much becomes toxic. Scientists calculated the limit. No fish could survive below 8,200 meters. The math was absolute. 2017, Mariana Trench. We found one at 8,178 meters, 22 meters from impossible. This is the Mariana Snailfish, Pseudolaparus swiri, the deepest fish ever recorded. Its body is soft, gel-like, almost unfinished. At 8,000 meters, pressure is 16,000 pounds per square inch. Imagine 3 SUVs stacked on top of your thumbnail. Its cells are 20% TMAO by volume. Any more, it becomes poison. Any less, the fish implodes. It cannot go deeper. It cannot come higher. When we brought one to the surface, it died. Not from pressure change, from heat. The same chemistry that protects it, traps it. And yet, down there, it's not struggling. It's thriving, feeding, laying eggs, building families, 22 meters from the end of possibility. We've explored less of the ocean than the surface of Mars. Everything you just saw lives in the part we've already mapped, which means this isn't the limit. It's the beginning. Because down there, life didn't escape impossible conditions. It rebuilt itself around them. So the question isn't, what survives in the deep? It's, what have we not found yet that makes the Mariana snailfish look normal?